Good morning, everyone. Today we'll be discussing our final year project, the flood prediction model using machine learning and IoT. For the machine learning part, we've used data in the CSV format of current rainfall in millimeters and hourly river level in meters. These datasets have date and time, current rainfall, cumulative rainfall, and river level. These data were recorded in between 2009 to 2018, and we acquired these data from the CWC. For our model, we've used various models like the random forest, KNNs, SVM, and the XGBoost. Among all these, the random forest has yielded the highest accuracy, and so we'll be moving forward with this model. Our model has a threshold of 1.7 meter river level. If the data that we provide, that is the date, time, year, and rainfall in millimeters, like suppose I'm giving 2024, 7th month, 9th. Time, let us suppose it's 12 p.m. Enter the year again, 2024. And rainfall, let it be 12 millimeter. So the output here shows the predicted or calculated river level is 1.7947, which is more than our threshold, that is 1.7. So the model shows flood as an output, like there's a probability of flood in the near future.
Now moving on, as you can see, we used 3 other models as well. So moving on to KNN, KNN we have the same thing, but we have used the main model here is KNN. Here we can see the various various evaluation matrices such as mean squared error, root mean squared error, coefficient of determination, and mean absolute error. These 4 evaluation metrics have been evaluated for all 4 models, which is the random forest prediction model, the KNN model, the SVM, and the XGBoost. Now, if you compare all the results, when we see that the values of mean squared error, which is the error that is present in the model, is least in case of random forest, as you can see over here. Is least is in terms of 0.005. In KNN it is 0.005. For SVM we have mean absolute error as 0.009, and for XGBoost the error is 0.0031. Since the error is almost highest in XGBoost, and in all the other models we use random forest. Now moving on to the output part. The output we have made the output using HTML and basic HTML, basic CSS. Now this is the indexing part, and this is the basic output which we have used. We've used static images for making all the output parts. Now moving to the output part. Here is the output. These are basic output. So as you can see, these are interface. Now we have the option to enter the date, month, time, and rainfall as required. If I give the month to be December of 2024, say 1st December 2024, year is December. The time, say the time to be 8:30 a.m. If the rainfall, say it's 20 millimeter, then as we can see, the predicted flood at 8:30 a.m. with 20 mm rainfall, then the river level will be around 1.8505 meters. Now, since our threshold is set at 1.7 meters, so there is chances of flood. So our model shows that there is a chance of flood. So we should take necessary precautions as needed. Thank you.
So this is the IoT part of our flood prediction model. This is basically used for monitoring of the flood water levels. As you can see here, this cup is a representation of the river, of the actual river. So as the water increases here, there will be a detection of the change in water level by the sensor monitored here. This is the ultrasonic sensor here, which senses the distance of the, which basically understands the change in the distance between the sensor and the river, which in turn tells our RF transmitter, and then the RF transmitter sends the information to our RF receiver. We have kept these two separated because we suppose that this is going to be stationed in a safe point, where it is top of the river. And also afterwards, we have our LED monitoring system, which will be showing in the flood location, nearby the flood location itself. Then there is going to be a GSM module. This is going to send messages to all the people surrounding our area using geotagging. And next, there is a ThinkSpeak server, which basically is our engineer to monitor the flood water level changes. As you can see, here is the water level indicator here. Like we can see, this is 22 centimeters. The gap between the sensor and the river is 22 centimeters. Now it's 21 centimeters. Now it's just 22 centimeters. The changing water level is monitored continuously and then updated to the servers. Will be sent to our to people nearby to tell them that there is a chance of flood or not. And now Avinash will show how the system works. Okay, Avinash.
Okay, so now I will show you what happens once the water level crosses the threshold limit. So here first we are going to increase the water level. So we will pour water into the bucket and we will see what will happen. So here you can see that we are pouring the water into the bucket and the water level is getting increased.
It is 21 centimeters now, as you can see here.
Initially it was
now it's 20 centimeters now.
Yes.
Yeah. Okay.
Now we are adding some more water into the bucket and let's see what is.
Now as you can see here, it's showing that the water level is high and the SMS is being sent. The water level high. And the SMS is sent. This is JSON model doing that. Now, as you can see here,
now in the ThinkSpeak server, that distance it will be updated. And since the water has crossed the threshold limit, a red LED will be turned on. So here you can see that the red LED has been turned on as the water level has crossed. So now as we can see in the LCD display that the water level indicating that is high. And in the ThinkSpeak server, we can see that the LED has been turned red. So now it's a clear indication that there can be a probable chances of flood. So what will happen? The GSM model that we have used, it will send message to the nearby locations indicating that there are high flood chances in that area. Thank you.